Welcome, my name is Dr. Arnab Bandyopadhyay. I am discussing or demonstrating the topics of hypothesis testing, which is relevant to the BTech of third semester data science courses, paper name Probability and Statistics, and course code BSC M301. I am Associate Professor of Mathematics at Dr. BC Engineering College and serving Department of Basic Science and Humanities. Now I want to start my discussion.
Now we want to come to the definition of the power of test. Power of test, statistical test, is the probability of rejecting the null hypothesis engine 0 when the alternative hypothesis is true. So have a note that what is the definition of power of test? The power of test is the probability of rejecting the null hypothesis is 0 when the alternative hypothesis is true. And power of test is denoted by, how it is denoted? Power of test is denoted by 1 minus beta. So this beta is what? Required to understand what do you mean by the beta. In last class we have defined beta. Beta is the type 2 error. It's not B, it is beta, but since I am using the computer keyboard, so is beta. Is the type 2 error. So for example, we consider these things that we are testing hypothesis H0 mu equal to 50 centimeters per second against H1 mu not equal to 50 centimeter per second. Suppose that the true value of the means, that is the mu equal to 52 when n equal to, that is sample size n equal to 10. We found that beta equal to 0.2643. So the power of test, that is 1 minus beta, is equal to 1 minus 0.2643. So this is the power of test. This is the power of test. Power of test. But power of test depends on the value of beta. Depend on the value of mu, because this mu has significant effect on. In last class I have shown that type 2 error beta depend on mu, and so the power of test, that is 1 minus beta, is depends on mu, because beta depends on mu. So obviously 1 minus beta depends on mu. In last class I have explained that power of test depends on the population parameters. It is written in last class. I will note down the fact clearly. So this is a one-sided and two-sided test. So this is the two-sided test. How? So have a look on the curve. Suppose you want to draw the curve. So suppose you was to draw the curve. This side and this side. I will note down the fact. What do you mean by two-sided test? When mu greater than mu 0 is this one, is coming from that. But when mu less than mu 0 is coming by that. So what is mu? Mu 0 is what? The mu 0 point is the middle point. Mu 0 is the middle point, that is this. This point is termed as mu 0. So this point is greater than mu. Greater than mu 0, and this point is mu less than mu 0. So that's why the terminology used. So This is one-sided. This is one-sided test. This is one-sided. But if I combine both of them like this, if I combine both like this one and this one, that is mu not equal to mu 0, that is coming from here, that it means I can write down here, that is mu less than mu 0 and mu greater than mu 0. So this point as a whole represent the two-sided test. Two-sided test. Two-sided test. Two-sided test means this one plus this one. Two-sided test. Have a note down the fact clearly. So this is the fact. Whenever we are considering two-sided test, we are taking both side matter. That is this one and this one. But whenever we are taking one-sided case, that is either mu less than mu 0 or mu greater than mu 0, then we are taking either this one or this one. But whenever we are taking two-sided test means what? Both the cases, that is mu less than mu 0 and mu greater than mu 0, both the cases are involved. But in one-sided test, only one of them are involved. So note down the fact clearly. So this is the example. Consider the pollutant burning rate problem. Suppose that if the burning rate is less than 50 centimeter per second, we wish to show the strong conclusion. The hypothesis should be treated as this one. So this is the null hypothesis. Please pay attention. This hypothesis is the null hypothesis. Null hypothesis. This is the alternative to be. This is the alternative hypothesis, and this one is the alternative hypothesis. Alternative hypothesis. So now question is that here the critical region lies. So this is the most vital thing, that is critical region. Critical region means which region? Critical region. Which region is called as critical region? Critical region is the region is the region where the null hypothesis H0 is rejected. The definition of critical region is given by, it is denoted by, it is denoted by C X in C H0, meaning H0 is rejected. So this is the meaning of critical region. Here the critical region lies that the lower tail of the distribution is of X bar. Since H0 is always a strong conclusion. So this statement that the null hypothesis produce the desired if H0 is rejected means since it is a I'm thinking about critical region. So the value of mu specified by the alternative hypothesis. Therefore, we failing to reject H0. Therefore, we fall to reject H0, that means mu equal to 50 centimeter. So this is the fact where H0 is rejected. Centimeter per second exactly, but do not have the strong evidence to support H1. So Bottle wants to show that Bottle meet the specification of the means. Bottles meet the specification of the internal pressure on bursting strength, for which 10 ounce bottle is minimum strength. So of 20 psi. So this is the value of mu we are specifying. This is the value of mu 0. We are taking this one in null hypothesis. So obviously alternative hypothesis should be mu greater than this one or this one, because this is a two-sided test if you consider. So this is the null hypothesis, that is age mu equal to 200 psi, and we are taking the alternative hypothesis, that is age1 mu greater than 200 psi or to age1 mu less than 200 psi. So this is the null hypothesis age0, and this is alternative hypothesis mu less than. So we are taking it in this way. So this is the problem. This is the problem formulation. So we have discussed how the problem should be formed on the basis of the discussions. Now we are discussing the p-values. P-value is the smallest level of significance that would lead to rejection null hypothesis H0 from the given data. So this is the definition of p-values. So p-value is the p-value is what? P-value is the smallest levels of significance that would lead to rejection of the null hypothesis H0 with the given data. So this is the definition of p-values. So now we are considering the p-value testing hypothesis. So these are the examples. This is another problem. So we are considering now. Problem. Example. Example we are considering for p-values. So this is the null hypothesis. This is the null hypothesis. Null, and this is alternative hypothesis. Alternative hypothesis. Alternative. Since I am specifying this one, that is here, so this gives a two-sided test. Gives us two-sided test. Clearly, I have demonstrated what is the meaning of one-sided test, two-sided test, and through examples, through problems, I have demonstrated the fact. So we know that either greater than or less than symbol, if arise, it is one-sided test. But if it is not equal to sign arise, then it is two-sided test. Two-sided test. Two-sided. Two-sided. So this is a sample size. This value n is a sample size. Sample size. Sample size. And this is the value, indicates population SD is known. Population SD known. This value indicates population SD is known. So this is the fact we're discussing. Suppose that the observation that mu is 15 centimeter per seconds, and figured that shows that critical region of the critical region. So these are the C values. Critical region, the test to this one. So this implies the critical region. Critical values. Critical values means region. Critical region C. X greater than mean, X greater than 51.3 implies age naught is rejected. So, because I have already demonstrated that critical region is that region in which null hypothesis, that is H0, is rejected. So, this is the meaning. Critical region. Critical region. Critical region is which region in which the null hypothesis H0 is rejected. So clearly I have demonstrated the fact, and the symmetric value is this one. So p-value test, that is alpha associated with the critical region. So we are denoting what? We are finding the p-values. So p-values, we want to have the level of p-values. So p-value test is the alpha associated with the critical region. So any smaller value, especially in the critical region, the test fails in the reject the null hypothesis. This is called this one. Where in critical region, I have demonstrated what is the meaning of critical region. That is, if a x bar, that is mean of x greater than 51.3, then the null hypothesis, that is the H0 is rejected. I have already demonstrated the fact. So p value is test to observe the in this sample. That is p value is, that is, it lies between this line. This x bar 48.7 to 51.3 line in this one. So we are using here the test statistics. The test statistics we are using test stat. Test stat you are using is equal to z is equal to mod of mod. Obviously you have to take the mod function. I am writing it separately. Mean of x, mean x minus mu divided by sigma by square n. So this is the state statistics we are incorporating here. Taking it mod. So this is the value of this one. Like if you use the value of test statistics, that is we used here, then we find the value this one. So actually Z is what? Z is test statistics. Test statistics we are using. Z is test statistics. Z is test statistics. We are using test stat. Test stat Z is equal to mean x minus mu naught divided by squared n. So this is the value of test statistics that we have got obtained here. That we obtain here, if you substitute it here, this is actually value of test statistics. Z is what? Z is nothing but a state statistics, nothing but it's test statistics. So if you use the value of Z, that is test statistics, we obtain here, then we were using standard normal table. We are using here standard normal table. So you should have the value of this one from standard normal table. Check for standard normal table. Standard normal table. So you have the answer like this one. So this is the actual value, that is the final answer. This is the actual value, that is the final answer is here. This is the p-values. This is the desired p-values. Desired p-values. P-values. So in this way I have solved the problem and I have demonstrated the problem. I want to go to the next point. The next point, demonstration. So this is the pictorial demonstration of p-values. The p-values is the area shaded region, that is x bar, this one. So this is the p-values here. You are actually having the p-values here and here. The area shown here. So the area that is here, p-values, you are claiming that it is a p-values. So this type of area, you are claiming that x bar, that is mean of x, is less than 48.7 for this portion, whereas this is claiming that you are denoting that mean of x greater than 51.3. So this is the value, and total probability you are having it 1. So this is the actual p-value. So this is demonstrated here, and this is the p-values combination of two facts, that is mean of x is less than 48.7 and mean of x greater than 51.3. This is the combination of two. That is p-value. So there is the connection between hypothesis and confidence interval. So please have a note that confidence interval, note down the fact that 95% 95%, I am writing the fact here. Note 95% confidence level implies 5% critical. 5% critical. Similarly, this is the note. Note number 1. Note number 2 is what? 99% confidence. 99% confidence implies 1% critical. But this is why. This is why. Because confidence implies the null hypothesis rejected. So null hypothesis is accepted. Null hypothesis accept. Null hypo. Whereas critical implies critical parameters implies null hypothesis rejected. Null hypothesis rejected. So that's why they are coming in opposite matter. That is, confidence is claiming it is accepted, and critical is claiming just opposite of that. It is rejected, and this is the connection between confidence level and hypothesis testing. So today up to this part. Next class we want to continue further.